we're going to finish off our week's work on polynomials today. But first of all, we're going to do a little bit of mental work. So no calculators, and I would really like it if you can try and do these without writing down any working. Okay? So I'll write down the questions. You can see we've got 2 pluses and a minus. Then we've got a money times 4 and a money times 20. Okay, so I'm going to hopefully get you to do these without showing any working. So what to do is each time I've written one down, pause the video, work it out in your head, and then check that you're right and move on to the next one. Okay, so first of all then, we're going to be adding 23 and 58. So pause the video, work that one out. Okay, so the answer to that one is, well, 20 and 50 is 70, 3 and 8 is 11, so we've got 81 altogether there. Okay, right, next one. 65, add 29. Again, pause it. And then when you work that out, 60 and 20 is 80, 5 and 9 is 14, so 80 and 14 is 94. Okay, the next one's a subtraction, which is a bit more tricky. So we're going to do 71, take away 25. Okay, pause it. So 71 take away 20 is 51. Take away another 5 makes 46. Okay, or you could do it 71 take away 30 and then add 5. That would work as well. Lots of different strategies for this. Usually you'll find that the subtractions take you longer than the additions. Right, okay, now this time 699 times 4. Pause the video. Right, so this one, I really hope you're not trying to do 699 times 4 in your head. I hope what you're doing is 7 times 4. So £7 times 4 is 28. But we've got 1p less than £7. So we've got 4 lots of that to take off. So instead of being £28, it'll be £27 and 96 pence. Because we've got 1 penny less than £7 4 times. Okay, and the last one, I want you to see if you can do £3.40 times 20. I'll pause the video, and then when you come back, let's do £3.40 times 2. So £3.40 times 2 would be £6.80, and then times 10, £6.80 times 10 is £68. Okay, so really huge well done if you managed to do that without writing any working down. Great stuff. Okay, so what we've been looking at this week is polygons. And we've looked at all sorts of polygons. We know what they're called. We've looked a bit more in depth at triangles and quadrilaterals. So today we're just going to have a nice quick recap of all the shapes that we've looked at so far. And we're probably, it's probably going to be quite a short lesson anyway. It won't take too long to do this. So, first of all, what I would like us to do is name each polygon and say whether it is regular or irregular. So remember, all we're doing is counting sides to start with. Okay? So, we know, we can tell the first one is a rectangle. Okay? So, a rectangle is a kind of quadrilateral. So it's a rectangle and it's not regular because this side and this side are not equal in length. So remember, a regular polygon has all its sides the same length. Okay, so what we've got here is a rectangle. And the other name for it would be irregular quadrilateral. But there's no way you would look at a rectangle and describe it as an irregular quadrilateral. You would just say it's a rectangle. Okay, now the next shape we can see is irregular because we've only got two sides the same length. The other sides are not marked as being the same length, so all we need to do is count the sides. So we've got 1, 2, 3, 4, 5, 6 sides. So what's a six-sided shape called? A six-sided polygon is a hexagon. So that is an irregular hexagon. Normally the hexagons that you see would be that sort of a shape, okay? But that's not always the case, because you can see we've got a hexagon that we wouldn't know is a hexagon until we actually count the sides. Okay, so next one then. Well, it's a triangle, obviously, and we've got all the sides marked as the same length, so it is a regular triangle. But remember, the special word for a regular triangle, where all the sides are the same length, is an equilateral triangle. Okay, next one, let's count the sides. 1, 2, 3, 4, 5, 6, 7, 8. And these sides are all marked as being the same length as each other, so it's regular. And 8 sides, it's a regular octagon. Okay, now the next one, we can see, maybe jogs our memory a little bit. We've got a kite here, and it's not regular because this side and this side are not the same length as each other. Okay, so it's a kite. And another name for that would be an irregular quadrilateral again. Just like the first one, that was actually a rectangle. Okay, so a kite and a rectangle are a better way of describing these two particular irregular quadrilaterals. Right, now this last shape, again, is irregular. Oops, Daisy, 2 R's please. Is irregular, because none of the sides are marked as being the same length as each other, so we just need to count the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can you remember the name for a 12-sided shape? It's like 210, so it's dodecagon. Okay, so do is 2, dec is 10, so dodec is 12. Okay, so well done if you remembered all those names. And then, got another example, another exercise to do here. Match each triangle to its descriptions. So each triangle should be matched to 2 descriptions. Okay, so it's up to us whether you pick a description and then match it to a triangle, or pick a triangle and find the descriptions. So I think I'm going to do it. You can pause it and have a think and then come back and see if you're right. So I think what I'll do is I'll pick the descriptions and I'll match them to the triangle first. Okay, so I'm going to look at the first one, right angled, and I'm going to look for the triangle that is right angled. And the only triangle that's right angled is this one in the bottom left here, because it's got a right angle showing. So that belongs to that triangle. Okay, the next description I'm going to look at is equilateral. So we've just reminded ourselves a minute ago that equilateral triangles have 3 sides all the same length. And when we look at which triangle has 3 sides all the same length, it's this one over here, because they've got the little dashes on the sides that say they're all the same length. Right, the next description here is isosceles. And remember, an isosceles triangle has 2 sides the same length. And there's only one triangle here that's got 2 sides marked as being the same length, so it's this one. Okay, So this triangle, now that we've got our two descriptions, is a right-angled isosceles triangle. Okay, so where are we up to? Scaling. Okay, so which of these triangles is scaling? So remember, scaling means all its sides different lengths. There's no sides that match. So that would be this triangle here. And the next one that we'll look at is acute angled. Remember, an acute angled triangle has all its angles acute. Okay, so there's only one of those that's got all the angles acute, which is this one. So this triangle here, now we've got two descriptions, is an acute angled equilateral triangle. Okay, and so obtuse angled, remember obtuse angled triangles have only one obtuse angle, and in this triangle here we can see that this angle is obtuse. Remember, a triangle can't have more than one obtuse angle because then the three sides can't match up. Okay, so this triangle here is an obtuse angled scalene triangle. Oops, not skating. Oops. Okay, so that was our three ways of, not three ways really, you've got three options for the lengths of the sides on a triangle, and you've got three options for the types of angles. Okay, so every triangle will be one of the sides ones and one of the angles ones, as we looked at the other day. Right, one last thing. Can you remember how many sides does an icosagon have? And can you draw one? Well, if you remember, an icosagon is the 20-sided shape. So I'm going to draw one here. I'm not using a ruler because it's a bit tricky on the iPad. So in this space here, I'm going to draw an icosagon. I'm going to start like this. So 1, 2, 3, 4, 5, 6, 7, 8, oh dear, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So let's just check those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Great. So that is an icosagon, but if you were to draw a regular icosagon, it wouldn't actually be far off a circle. Okay. So remember how, like, for example, our octagon that we looked at? That's an octagon, if I'd drawn it properly. And if you imagine each of those sides being split into like two sides, make it like that instead, then that would give you a hexadecagon. That would be a 16-sided, so we need to make even more sides than that. So you try and draw your own icosagon anyway. If you try and draw a regular one, you're going to find it really quite tricky. So you can always post your answers on the page on Teams. You can either make it the general page or the daily work page, don't mind. But if you've drawn a good icosagon, you can maybe even make it, like, try and get an icosagon that's the shape of a dog or a tree or something. Okay? Anyway, I hope you have a great weekend, and I will see you next week. See you later.